Good afternoon. Welcome to the second session of Tech Talk by TMO. This is a part of an ongoing series of sessions conducted by TMO, and every Friday at this time, you can expect someone from InApp taking a session on some technical topics. Today, we will be talking about device management with AWS. Any questions you have can be mailed to TMO later, and we will be trying to answer those questions as soon as possible. We'll also be recording this session and will be made available to you later. So let's jump on to today's topic. Everyone can see my screen, I think. Yeah. So Internet of Things, the most common term today right now. Before the cell phones are connected to the internet, what we could do with that phone is basically make a call or of course you can text some messages. The change that made the internet, when the device is connected to the internet, you can read a book, you can watch a movie in the phone, or listen to any song, all in the palm of your hand. The main point is that connecting things to the internet yields many amazing benefits. We have all seen these benefits with our smartphones, laptops, and tablets. But this is true for everything else. And I stress everything. The Internet of Things is actually a pretty simple concept. It means talking all the things in the world and taking all the things in the world and connecting them to the internet. Now you can see a series of examples in this. Right now you have a farm that have some kind of sensors that this is all a real world application of IoT. Now you can have a farm having some sensors, and that will allow whether the water needs to be sprinkled, depending on the moisture of the atmosphere or whatever sensing capabilities it have. So everything can be controlled remotely. Now you have door automatically open, or maybe on a remote home. If you're sitting on a remote country, you can see what's happening on your home and control the actions like switching off or opening a door. There's a lot of things happening around the world right now with all these things. Okay, so we are familiar with the term smart. Smartphones, smart devices, gadgets are all smart. When something is connected to internet, that means it can send information or receive information, or both, right? This ability to send or receive information make things smart. To be smart, a thing is actually a device. Everyone is familiar. So thing is actually a remote device, a mechanical device or an electronic device. So in our world, in IoT, we will refer those devices as thing. As I said, to be smart, a thing doesn't need to have a super storage or a supercomputer inside it. All thing has to do is to connect to internet and connect to a super storage or a supercomputer. You can receive instructions from that computer and act on those instructions. That is how these smart devices work. That means being connected is awesome. In the Internet of Things, all the things are being connected to the internet can be put into three categories. So it's some issues with our microphone. Okay, so we were talking about when in the Internet of Things, all things are being connected to the internet can be put into categories. Things that collect information and send it. things that receive information then act on it, and things that do both. So as you can see in this diagram, in this picture, you have a pyramid there. Bottom is sensing, right? Sensing. So the sensing means you have a sensor. I'll tell you an example. A temperature, right? Sensing the temperature of a room, and sending it to the internet so that the AC, the air condition in that room, can be controlled. So that is the basic thing of a smart device, sensing what is happening around and informing some kind of logic in the internet. Automation comes next. Sometimes you can walk into a room, the light automatically turns on. Another example, it rains for 2 days and the farm's irrigation system automatically shuts off. This is all, you sensed something around, right? Somebody walks into your room. There is a sensing there that it automatically identifies a person is actually entering the room, and an action happened, right? The light automatically turns on. So this is automation. So a smart device will have a sensing feature and it acts on it with automation. Remote accessibility is to access a product remotely via smartphone or tablet or computer. An example is track your dog step from the other side of the world, right? You can watch what your pet is doing from the other side of, using an IP camera. You can actually view what is happening inside your room, and you can take actions on that. So remote accessibility is another feature of the smart devices. Awareness, of course, a device starts getting really smart when it begins to understand and analyze its surroundings. That means a device can sense where it is. Of course, GPS. What devices are nearby, right? When you walk through an airport, your device automatically connects to a Wi-Fi. So the device actually knows a Wi-Fi device is there, and it can, or a Bluetooth endpoint is there, and it automatically connects. So it is aware what is happening around. So that is the awareness of the system. And then comes the learning part. Okay, learning device automatically identifies the patterns over time and changes the response, right? When you for an example, an advanced car, an auto drive car, could learn how to make turns over the first few weeks and of driving and adjust the pattern, like the suspension, to provide better performance. So it could be anything. It could be anything like learning. It's these features actually make the devices really smart. Right. We'll go to the next slide. We'll talk about a little bit about device management. So you have a device, you have internet connectivity, and you have a software that actually listens to the device and send instructions to the device to act accordingly. So device management is actually a big process. Like there are consider in Internet of Things. That means billions of devices, managing billions of devices in the world. So now with IPv6 coming in, there are possibility anything in this universe can be connected to internet. So the device management is managing those huge amount of systems. So how do you manage? You can see that Apple releases a firmware update every 6 months or so. So how do you manage? Now, you cannot push these device firmware updates to all the devices at once, so that every device will try to uh, download that firmware at a single time and everything breaks. So you need to manage, how to manage, how to change the device behavior. So that is why even the device management includes device registration, its authentication, authorization is as well, right now, what this device can do, a particular device. You are managing an individual device separately, out of those million devices out there. The configuration of the device, provisioning, monitoring and diagnosis, what that device actually does. It collects the information. If anything happens to that device, no, you need to troubleshoot as well. So it's like device management means you manage each individual devices out of the millions of devices that can connect to your system. So this application have different services, a file management, device management, everything that is there, right, to control the device working. We'll talk briefly about the life cycle of a device. So it's actually the device need to be onboarded to the system. So when a manufacturer creates a device, when the device reaches the customer, that is when the device needs to be onboarded. The distributor sends it to some location, and a customer purchases it. And when the first time that device is switched on, you are onboarding the system. So you need to push in a initial configuration, and you need to provision the device for the initial state for that device. So authentication, authorization, and secure communication, that is the deployment part. You need to have a proper authentication. The device cannot do something. It can, the roles, what that device can do, each device can do, is the deployment part. And then you have a maintenance part where you need to push firmware updates or update the configuration state, or update, if the device security is compromised, then you need to update the certificates of the device. And when the device is useless, or maybe after a couple of years, you want the device to be non-active, should not be connecting to the system, then you will revoke the identity of that device, and then serialization is just deleting everything of that device from the system. So there are enterprise platforms available to manage devices, but we will be talking about the cloud platforms, popular cloud platforms today, available today. That includes a lot of very common platforms. Google Cloud Platform is there, IBM Watson, Oracle, Amazon. IoT for beginners is also a good platform. Azure is there. So these slides now, the most popular platforms is mentioned here. Just briefly, we will analyze, we will look into Google Cloud Platform before we get into the details of AWS. So Google IoT services are called Cloud IoT Core. There is a publish subscribe this is where the rules, like which action should go to what should be, if the device sends some kind of information, you need to collect that particular information and act accordingly. So there is a streaming, like everything that is sent to the Cloud IoT Core. So that is called ingest, data ingestion. When the device sends something to the cloud, that is called ingesting data. And the publish, subscribe, and the cloud function decides it needs to, the data needs to be streamed into maybe a Firebase database in case of Google Cloud Platform, or BigQuery, and we need to store that data or act upon it. So this is the Google Cloud functions are the as you are aware, the function as service, you are getting a platform in the serverless cloud. So the cloud functions are the specific name for like Lambda in AWS, you have cloud functions in Google. So you can have a web app, you can notify that a person enters a room through a web app notification. You can act on that data anyway. You can. So there is the same process is available for Azure, Microsoft Azure. I just just put it here because there are other platforms available, just to make aware that. So it is called IoT. X devices will be sending to the IoT hub. AWS will call it IoT hub. Azure will call it IoT hub. Then data transformation can be there for you can do warm path storage. These are all specific terms for Azure IoT, and the stream processing and reporting tools are there. Analytics are there. So this everything that is available in AWS is also available in Azure IoT. Yeah. Now we'll talk about AWS IoT, and we will get into more details of AWS IoT. So AWS IoT architecture is like the default device. Before we have everything reaches the gateway, there is an authentication and authorization. There is a device registry. Device shadows manage the configuration. The rules engine acts on the message and stream it accordingly. Where should it go and all. So that is that is what AWS have. AWS IoT. We'll walk through each of these services in this session. So we have a serverless architecture of DMS. This is actually implemented here in our InApp. So we have implemented the same for the Crane project. So MQTT, we will talk about MQTT. A device is sending some data. IoT core, it reaches IoT core. IoT topics, we will discuss about. That is what kind of message. It identifies a particular message through topic. IoT rule will do a kinesis, decide whether it should be written to a kinesis or or it should go to a Lambda, act upon it, and there are other services available here. Whether that can be made use of based on the data. So another application, the AWS IoT console is also a serverless application. It's a web application that is hosted in S3. We don't have an EC2 there. That's my point, and that connects through API gateway and send instructions to AWS IoT core, and that instructions will be sent back to the device, and the device can act on it. So all the device communication is basically uses MQTT architecture, the MQTT protocol. The basic reason for MQTT protocol, selecting MQTT protocol is it's less load. Like the HTTP or other protocols have this the devices doesn't have that memory or bandwidth to talk HTTP. The devices we should need to consider devices having very low bandwidth and very low memory in that. So the MQTT protocol actually satisfies that devices and that condition, and it's basically a publish subscribe mechanism. You publish to a particular topic, and a subscriber, any subscriber, anyone familiar with queue, a queue, any queuing system will be aware of this topic, publishing and subscribing mechanism. So for MQTT, there is the security is it's basically TCP, but the transmission is controlled through TLS. TLS is the encrypting data in transit, and that way we can make sure that the data is secure. There is a central broker system, that is the middle part, the central broker system that billions of devices on the internet will be sending data. Now, that needs to be scaled up. Those broker, the MQTT broker, it has the capabilities to scale, and it actually reduces the number of packets fall into a particular topic, and a single topic can be scaled separately. There is one more thing called quality of service, which determines the delivery of that message on that topic. It can be at most once, or at least once, at most once, and exactly once. So AWS IoT only support at most once and at least once. Go to that next. So this is the AWS platform. This is the AWS IoT platform. Things are all devices. The device, the gateway is there, authentication, authorization, these are the services available. A message routing through IoT rules. A registry is the thing registry in the AWS IoT, and a shadow. And it actually communicates with memory logic, what kind of data needs to be stored, or what kind of analytics that needs to be done. So that is what AWS IoT platform is all about. So the devices need to be connected securely. So that is where AWS IoT connects securely via X509 certificates. So if you're there, you need to register. You can have a Amazon CA certificates available there. That needs to be your certificates needs to be signed with either Amazon CA or some kind of CA certificate that is hosted in Amazon. So TLS version 2 is available, should be there for communication, and elastic publish subscribe model, that is what the IoT broker system go from 1 to 1 billion devices by directional connection. So multi protocol, you can connect with other protocols as well, but MQTT is the preferred way of talking to AWS IoT on the device. I'll just talk about device onboarding. So an IoT thing is associated with a certificate. A certificate identifies the device in IoT, and a set of policies are associated for that certificate. So that policy decides what action that device can do. Now, whether it can send a message, or whether it can receive a message, or whether it can connect to S3 and read a file. So all those are defined in those policies, and you can group those policies into something called a thing group, and you define the policies for that thing group, and you associate all the devices to a particular group. Those group of devices will have a certain set of policies defined for them. When the device needs to be onboarded, there are multiple ways in AWS IoT to onboard a device, through API calls, or single device provisioning, or bulk device, or just-in-time provisioning means just-in-time registration and provisioning means when the device first connects to the IoT, it will provision the things, and it will create the essential details in AWS. AWS IoT rules actually defines when a message arrives into. I need to talk about Kinesis streams here. So the message needs to be put into stream when a device connects to IoT using MQTT and send a message. You immediately need to store it somewhere, without losing the data. So streams are pretty much useful there. Kinesis stream is one of the most popular thing, and you can read that data using rules. You can have a simple query, select star from things. These are our query language, simple SQL statement, and you can just read those messages and define a rule whether that message should go to Kinesis or to a DynamoDB or to S3. You can define anything. Though that is what this rule actually is useful. Device shadow, the device shadow is actually what the configuration state of that device is. You need to manage the configuration state. You need, for an example, you need to change the language to Spanish from English. So you just need to, on a single click, you need to manage that from a remote web application. So the IoT device shadow is what is useful here. There is a desired state and reported state. Desired state is what kind of state is desired on that system. So some mobile application somewhere wants to change the color of that application or the device, the LED to red. It will change the desired state to red, and once that action happens, devices report back in the reported state. Actually, this is the shadow flow. Devices publishes their current state. AWS IoT will store that somewhere in that JSON data store, and devices will actually request for that is the MQTT publish subscribe mechanism, where devices will be subscribing for any updates. So once the devices, once any application request for a shadow change, all the subscribed devices will get that, and it will be reporting back. Devices will be this is my current state of that device, and you need to make those changes. And once that change is made on the device shadow is again updated on the reported state. This is a simple example of the flow. This is a simple JSON. A DMS updating the device configuration in IoT core. IoT core creates the payload. The desired state is updated, and the devices updating the IoT core with the reported state. So before we conclude, I want to mention about the IoT jobs as well. So IoT device job or over-the-air updates. If you want to reboot a device, that is called IoT jobs. So IoT jobs actually, there is a job document here that defines what action. If you want to download a firmware from some location, a job document will have that information, and AWS IoT will push that job to that particular device, and the device will act on it. So I think that's all we have for now. Thank you.